In this video, I want to review how we build confidence intervals for both means and proportions, as well as just revisiting how we solve for a sample size. A simple random sample is taken of 50 patients undergoing a certain surgery to see how long it takes the wound to clot. It is found that the clotting takes an average of 6.2 minutes with a sample deviation of 5 minutes. Find a 90% confidence interval for the mean length of clotting time for all patients undergoing this certain surgery. So, remember our 4-step process that helps us kind of get our way through this. First thing we're going to do is state. We're building a 90% confidence interval for the mean length of clotting time for all patients undergoing this certain surgery. Be very clear here when you write these statements that you're doing this for all patients. We know where the sample lies. Okay, we're trying to make an inference about the population based on our sample. All right, the plan portion of this. This is a sample mean problem. It is sometimes difficult to see the difference, but read the problem and look for the context. This is an average. This is a mean. And the other big red flag is sample mean problems have to provide you with a sample deviation or a list of data in which you could calculate the sample deviation. So remember that kind of zero condition is always, was it a simple random sample? The next condition is, was my sample size of 50 less than or equal to 1/10 the population of all people that have this surgery? I'm just going to write patients for now, okay, for this surgery. Okay, and remember your last condition then is the sample size larger than 30. It is. If it wasn't, then you'd have to know something about the parent population. For instance, you'd have to know if it's normal, or you'd have to be given data so you could graph it and look for outliers or skew. And but in this case, it is large enough, so we are allowed to just proceed. So for do, this is where we go to our calculator. We are going to make a T interval. So we go into our calculator to the stat menu, stat, and then over to tests, and we choose T interval. This is number 8 on your list of tests. We're putting in statistics, the mean, deviation, sample size, confidence level. We calculate it. Here is our interval. So finally, we conclude. Okay, so we are 90% confident that the interval from, I guess I could real quick just fill this out, 5.02 to 7.39 captures the mean length of clotting time for all patients undergoing this certain surgery. I have one follow-up to this. Let's look on the next slide. If we wanted the margin of error to be no more than a minute, because right now it's a little bit larger than that, right? It's about 1.2. So if we wanted the margin of error to be no more than a minute, how many people would we need to sample? All right, so I plopped in a couple of things from your formula packet that you hopefully have or have printed it out. A confidence interval is always built with this formula, statistic plus or minus critical value times the standard error or standard deviation. This part represents the margin of error. So we just fill these things in. So a critical value here is typically our Z star. And that's what we use. Even though this is a sample problem, we typically use Z star here because otherwise you really have too many pieces working at once. Because remember, the T is a function of degrees of freedom, which is a function of sample size, and we don't know that. So we go to 90%, and this is going to be our critical value, this 1.645. So 1.645 multiplied by the standard deviation of statistic. Remember, we were doing sample means, so this is it. Standard deviation was 5, and we're solving for the sample size. This needs to be equal to 1. Now, my recommendation to you is to multiply the 1.645 times 5 okay, to multiply these together right away in the numerator. So we have 8.225 over the square root of n equals 1. Then multiply both sides by the square root of n and divide both sides by 1. So it almost looks like the square root of n and the 1 switch places. And then, of course, square both sides. Well, 8.225 divided by 1 is 8.225. So when I square it, I get 67 point something. Remember, we always go up. So the sample size needs to be 68. So I need really to increase this by 18 additional people in order to get the sample size or the margin of error down to what I want. Let's do one more problem. A simple random sample is taken of Minnesota residents about the Super Bowl. Residents are asked if they would try to buy a ticket regardless of cost. Of the 860 residents questioned, 88 said they would indeed buy a ticket regardless of cost. Create a 95% confidence interval for the proportion of all residents. So this is a proportion problem. Okay, so a little bit different process, but first thing we do is still state. Okay, so I put this in. All right, our plan. Well, we still have a simple random sample. Our sample size, 860, less than or equal to the 1/10 all Minnesotans. And remember, we have a little bit different follow-up. Condition 2 here is that the sample size multiplied by the sample proportion, which remember would just be 88 divided by 860, that this is, of course, 88, that this is bigger than 10. Now, I'm also going to write down, because we also need to do the complement times the sample size. This gives us a little bit more, this is a little bit more of a intense check than sample means. Because remember, with sample means, we just say, well, it's bigger than 50, or we do a graphical check and say, yeah, there's no outliers. This is a little more intense calculation. That's because we are still, with proportions, going to use z. Okay, so we need to do a little bit more. All right, do. So the calculation here, please remember, you go to your stat tests menu. This is letter A, 1 proportion z interval. You see I typed in 88 out of 860. There's my level. Calculate. Here is what I would report, just that interval. So, your conclude. All right, we are 95% confident that the interval from 0.08 to 0.12 captures the proportion of all residents who buy a ticket regardless of cost.